Another reason why your system might be taking
very long to load is because of your dependent, or that particular endpoint is dependent on some third-party integration, which technically you could argue that it's not your fault, but the users don't care. They just want to use the application and get it to work. For example, your bank application, you have to query NIBs, NIBSS, you have to query certain verification IDs, certain third-party tools. And all these are necessary integrations for your system to work. You've optimized your own, but these guys are slow. So your application now seems very slow. You make a transfer and it takes a very long time to be resolved. This could seem like a very big problem to you. And it's one of the major causes of actual inefficiency, high latency. So how do you resolve for this? There are two ways you can actually optimize when you have third-party integrators that seems to be misbehaving, that seems to be very inefficient, and they are causing a very high latency. One of it is by caching the request and the response, and the other is by actually using the asynchronous logic. Now, the other approach you can use, share with me in the comments, like I would always say. Don't forget to like and subscribe. And so up onto the caching mechanism. If I've made a request to a third-party provider to fetch particular account details, I don't necessarily need to make that same request the second time. I can store it in my local DB. So for example, if you look at popular sign-in with Google, when I click on sign up with Google to an application, and I sign up with Google, Google provides this application with an image, my profile picture. If I now go ahead and change my profile picture on Google, usually it doesn't change on these applications that I used to sign up with Google. So there are some applications that I really have old profile pictures I've used when I was a lot younger, and they don't change. And that's because of this application decided to cache my profile picture locally within their own database system, so they don't have to query Google every time for my profile picture. And this would reduce at least the time between the requests, to reduce the latency a little bit. Another way to think about it is if you need to fetch maybe the list of banks from NIBS or from a certain provider, or the list of companies available, you fetch it, you store it in a local database, and you can say, okay, I'm only going to be fetching it every day as opposed to fetching it every time a user needs this record. This would then improve the performance. So that's caching, right? You fetch it once. The first time it might be a little slow, but consequent times, especially if it's a request that doesn't change as much, if it's a data that doesn't change as much, you just fetch from your own local system. And you don't need to be as reliant as a third-party integration as possible, as much as you would have been. Note, if you do this for something that changes a lot, like account balance, it could lead to problems. So you have to be very conscious when it comes to caching. You have to be very conscious about invalidating your caches. You have to be very conscious about making sure your caches are stored up to date with the source of truth record. You don't want to have a lot of stale records, except it is of no real consequences. Another approach to take is by using asynchronous logic. So you don't actually have to make the request in real time to the consumer of your API, of your endpoint, or to your client. So for example, I want to do a verification, right? An ID verification. I take a picture of my identity card. I send it to the backend. But the backend actually has to implement a third-party provider to verify that ID. So one thing they could do, which will be very poor, would be to keep the requests on, or to keep me waiting, to keep the connection open. And then they make a request to the third party. The third party takes certain seconds for you to verify because there are a lot of pictures involved and maybe AI, and give them a response, and they give me a response immediately. This will be highly inefficient because if there is, due to network inefficiencies, or many times even regular requests actually just timeouts, what happens is I've lost that chain of track. I've lost that chain of thought of that record. A better approach would be to do these operations asynchronously. So you make a request to the backend. The backend tells you, oh, guy, I've seen your request. I'm going to process it and let you know when it's ready. Go ahead and have a good time. Go get a coffee, go eat, go out with your friends, go play. And then behind the scene, the backend now makes a request to the third party. When it gets a response, it calls me back using SMS, email, or even just a webhook call if it's an API that, oh, your result is ready. Don't worry. You can come back now. I'm ready for you. Like this, the latency of the whole system has been reduced, and it has saved me a lot of time and created a better user experience for me by running the code asynchronously. And this can be thought of even a lot of ways. You can abstract it to almost everything you need to do. Do the work you need to give the user the response in the synchronous flow, and dump every other thing to an asynchronous flow. Let them run asynchronously behind the scene. You don't want to be holding users down, to be holding requests down while you do a lot of complex work, a lot of writes that doesn't need to actually be done while the user is waiting. Now, note also, the problem with this is you don't want to also lose user records, so you have to implement, it's not really a problem, right? But you have to be cautious to implement certain things like queuing system, record storage, asynchronous logics, so that whenever an error occurs, you can actually retry on your back end without having to require a new set of input from the user. Because your users will be frustrated if you tell them, go ahead, I have everything figured out. I'm going to get your ID verification ready. And they call back again and they're like, actually, I need another data from you. That's going to be annoying. So you want to store this data in a temporary storage, maybe an in-memory storage, a RAM, a Redis, or a queue, so that you can process again whenever the third party fails. So that when the user comes, the user doesn't have to put in the input all afresh. So yeah, that's that about when you're dealing with third party. The other approaches you can use. Let me know if there is something you don't understand or if there is a different approach you think we can use to actually process this. We're all learning together, right? We're all trying to improve ourselves. So leave a comment, make sure you like and subscribe. See you in the next video.